Hi, my name is Jaelin. This is my final KaggleX showcase of my project called Receipt OCR. A little bit of my background. I am currently a machine learning engineer at Omdana, and I have experience in research and innovation for over 10 years. And I have over 2 years of data science and machine learning experience, and I won a few awards. And I built my first iOS app, malaria.ai, using computer vision. And my final Kaggle project is the Receipt OCR web app, and I wrote 4 Medium articles about this. It's a brief summary of my project. So my learning objective was to learn what's beyond the notebooks. So I kept hearing about the importance of coding in a production-ready way, and that includes coding in VS Code or alike, and deploying to the cloud, and using GitHub repository, and understanding the entire lifecycle of MLOps, and writing a few articles to share your knowledge and participate in the growth of the community. So what better way to do this than learning by real example? So I looked at the grocery receipts that I have piled up in my own home, and we share the receipts cost, the grocery bills with between couples. So my goal was to reduce financial stress for couples by making splitting grocery bills easy and by helping them better understand their personal finances, in turn improve relationships. So the solution, the Receipt OCR app, analyzes and scanned receipts and outputs who owes to whom, how much, in real time if you're splitting half and half. So it also provides insightful statistics to understand couples' individual spending habits. The status of this app is that the web app deployment in the test mode is complete, and iOS app deployment has been started. So this data science topic applied in this project is very broad. So we apply the entire life cycle of MLOps to understand what goes in there. So I started with the data collection and pre-processing, model selection, model deployment using Flask, and database connection with the Firebase, and model deployment with the GCP. So what is deployed? These are the screenshots of the deployed web app, and user logs in with authentication, and Firebase NoSQL database is connected. So collected, the OCR results is saved in the Firebase NoSQL database, and the receipts are stored in the Firebase storage, and it is deployed through Cloud Run. So on the right side, that is what users can see about who paid for what, when, and the details of the receipts. The OCR information that is extracted is categorized as multiple graphs, and this insightful graphs helps for users to understand their spending habits better. The architecture of this app includes multiple components. First, the Python to build this model and the pre-process the input, and experiment tracking through weights and biases, and deploy to the local host using Flask, and then deploying to the web app through multiple process, which includes gUnicorn to manage the throttling, and Docker images to containerize the entire pre-processing steps and model prediction steps, and the artifact registry in GCP to host this built Docker image and do the model version control. Sometimes this Docker image can fail during the production, so it is a good idea to have multiple Docker images ready to be staged and to be for production. And then it is deployed to the microservice using GCP Cloud Run, and it allows us to do a latency monitoring as well. So it's a very interesting feature. And then once it's deployed, it communicates with Firebase authentication and real-time database and storage to allow the users to securely look at their data and upload their receipts and go back and edit their receipts component if the OCR result is not accurate. So the Flask component is the backbone of this entire app, and which includes the pre-processing steps. So you can easily look at the flow chart of this components, and the experimental tracking is done with weights and biases, and I compared 113 receipts OCR results with the ground truth. And you can see it's a pretty good result throughout the price and store and date information are correctly extracted and paid by, which is derived by the card number recognition, was a little bit less. And you can see some stores have a better match, better results than the other stores. And I think it's coming from the how faded it is over time. The receipt becomes, and some stores receipt fades a little bit fades a bit faster than the other. As far as monitoring goes, there's system monitoring of the CPU utilization and memories and so on. And once it's deployed to production, you can also continue monitoring the latency, CPU, memory utilization, and traffic to your website through CloudRun's very nice dashboard. So as a next step, I started designing the UI of the iOS app, and it'll be interesting to further integrate grocery stores APIs and match frequently bought items with discount opportunities for users, and that's coming. So for the lessons learned, I learned quite a lot from this project, which includes image augmentation, tesseract OCR model, regular expressions, weights and biases, and how to code in VS Code and Terminal rather than just notebooks, and creating the Flask app from scratch using GUnicorn. You manage the production throttling, and creating a Docker image and connecting to the Firebase NoSQL database, and learn how to use GCP in multiple services. And pre-processing images for receipts are another interesting learning that I got from this project. And one thing here, an example on the right side, is that the four-point transformation actually doesn't work very well for this receipt case that has a torn part on the top right corner because it distorts even further. And this is how I understood creating a Docker file. Before, it was very scary how to do it, but now I understand it's just sequences of commands that you ask the system to build this base operating system, and copy over your files and update the OS and the install necessary packages, and you tell them to use GUnicorn to deploy to the production. And a bit more details here. And I ended up writing 4 Medium articles from this project, which I'm very happy with. These were my first ever Medium articles, and I think it's getting a very good response to it as well. So people find it very useful, and I wish you could check it out as well. And that's not it. There are more coming. As you can see here, there's already 600 something words written, 400, 500, 150 words for the upcoming Medium articles. So stay tuned for that. And another thing that I'm very happy about from this project is that I learned how to use GitHub properly and share my code in the repo and write the README file in a proper format, which includes the key information such as installation guidelines and how to run, how the input and output and limitations of the app, and the components of the flow chart of this code, and the references and license information. So as far as the learning objective concerned, I have achieved all the things that I set out to achieve 4 months ago. So I'm very happy with that. And you can see my work in these places. Thank you very much.